Okay, let's move on. Our next speaker from Red Hat, Wei Fu. Let me introduce Mr. Wei Fu to everyone. それでは Wei Fu さんをご紹介いたします。Wei Fu is a senior software engineer in platform enablement department at Red Hat Software, Beijing. Wei Fu さんは Red Hat の、プラットフォームエネブルメントの、シニアソフトウェアエンジニアです。He received bachelor degree from National Virtual University at 2007. Before working for Red Hat, he worked for Dinaro as enterprise engineer, Java engineer in China, and worked for a couple of companies as Linux kernel engineer and Linux system engineer. 2007年にナショナルファーチャル大学を卒業しました。卒業後いくつかの会社で Linux システム、カーネルのエンジニアとして働いた後、リナロにジョインしてエンタープライズエンジニアとして活躍されました。そして現在、レッドハットにて働いています。Today, he will talk about Red Hat RISC-V participation, Fedora and Firmware development status. 本日は、Red Hat の RISC-V への参加、Fedora や、Firmware などの、開発状況について、発表します。Okay, please start presentation. Thank you.
皆さん、おはようございます。私はフイです。私は東京が好きです。This is my first time in Tokyo, so I'm so glad to be invited to have a presentation here. I'm the senior software engineer from platform enablement team of Red Hat, so I'm happy to give more update about Fedora on RISC-V. So so before I start, I heard a very good question about people asking, will we focus on software? Yes, as Red Hat, we are a very good software ecosystem participator. So we always focus on open source software. When we looking at there is an open source hardware RISC-V, we found a great opportunity. So 3 years ago, one of our engineers already working on that. So let me give you, allow me to give you a status update of Fedora on RISC-V as usual, because it's the first time I have a speech in Tokyo, and then because I'm the software engineer, so I will give you some information about how to establish a development environment in your laptop, which running Fedora 30 or later. And at the end, if you're really interested about Fedora on RISC-V, you can really download our imaging and run on QEMU directly. So it is all about software development. So let's start it. First of all, I will introduce some history of Fedora on RISC-V and facility status and the board and the platform we are support. Let's the timeline of Fedora on RISC-V. 3 years ago, one of our engineer who is not really working on platform environment, he is working on Verting, but he really interested about that and start working on it and made RPM build building on RISC-V and running on it. It's a milestone for Fedora on RISC-V. So, and then 2 other engineers joined them and said, and 2 months later, they made first bootstrap successfully running on RISC-V. But At that time, the upstream haven't been really finished, so they wait for two years and start another bootstrap. And at the end, they start once all the pieces being upstream, they start last and the final bootstrap for Fedora 28 as the final, bootstrap. Then they start establish a Koji system. Koji system is a native build system, which is also distributed compilation system. All the Fedora package will be built in this system and then wrapped into an image we publish from that system into our repo. So last year, we also enable graphic desktop on RHEL software, RHEL hardware, which is Sci-Fi Unleashed development board. 2 months ago, there is a historical moment for Red Hat. We officially joined RISC-V Foundation. So we are the member. We are doing more participate. We are participating more even than ever before, more than ever before. And in our system right now, produce different version of Fedora imaging. So this is our Koji system. You can have a big picture of that. Right now, we have 3 Unleashed board running in the system, help us to do the native build. We also have 142 QEMU virtual machine running on x86 64-bit server, help us to do the native build. The whole facility was controlled by 2 high-performance server. So you can see all these things is a little bit complicated. So thanks to Sci-Fi and Western Digital, they donate some server and development board to us. Thank you very much for that. So in this Koji system, it produces all kind of RISC-V package for Fedora RISC-V package. It includes the debug info, debug source, and the source package. Right now, there are 2 activated projects. One is Fedora 31, another is Fedora 32, which is so-called RHEL because it's the next version of Fedora. And we have 2 reports in the world. One is in the Fedora official website. Another is a mirror in Princeton University. But recently, under the help of a Chinese company, we also have a mirror in China. So if you are interested about that, if you want someone download our package more quickly, you can establish your own mirror. There are 3 types of disk imaging is being built right now. One is minimal, developer, and Fedora Gnode. So because Fedora Gnode is a very big imaging and very complicated, so it consumes a lot of resource. We not really produce this imaging oftenly. So only developer will be produced nearly every week or every day. So there are 2 right now. Fedora imaging, Fedora imaging originally support 2 hardware or software. You can run Fedora imaging directly on QEMU or libvirt QEMU. You also can run it directly on Sci-Fi Unleashed, which is the first 64-bit RISC-V development board. But if you want to also try the expansion board with PCIe graphic card and SATA disk, you'll need some more patch on the kernel. Then because some of the patch haven't been upstream, so you need some more patch set to the kernel. If you recompile the kernel, you also can have a graphic Gnode desktop on your system. You may can see some demo in some RISC-V event that's running Fedora on it. Let's think we have prepared for the demo and we can reproduce the kernel. So we also test our Fedora imaging on Andes development platform, and one of the Chinese organization called ICT, which belong to Chinese Academy of Science. They have a very advanced FPGA cloud development platform. So RISC-V means rich hardware ecosystem. Everyone can produce their own RISC-V chip, or everyone can produce their own IP code. But we also want to reach the software ecosystem. Red Hat and the Fedora community always open. So if you have a RISC-V 64-bit system, or you want to make Linux running on it, make some Linux distribution running on it, we are very happy to help. Please contact with us. Let's go together and promote RISC-V software ecosystem. So I have finished the big picture of Fedora on RISC-V. Let's talk about some more detail about technology and how to do the Fedora on RISC-V development. First of all, you may ask, if I want to recompile the software, where I can get the cross tool or cross compiler. That's the first thought of some developer. Okay. So if you want to do a cross compile, you just need to DNF install the cross compiler in Fedora 30 or later. You don't have to download some cross compiler from some website which is not unified. We already provide the cross tool in our Fedora system. But normally in Fedora, we're not really doing cross build every time. Cross build is a bootstrap part of bootstrap. So we encourage you to do the native build on RISC-V QEMU or real hardware. So if you installed our Fedora developer imaging, you can have all the build tool in your system enough to build all the RPM package for you. So we just talked about QEMU. So if you want to install a QEMU, please install the latest one, or you can compile it by yourself. You just need to download or git clone the latest QEMU from upstream and recompile it. But if you want to install it, please make sure there is enable one of the repo and then install the latest QEMU in your system. But you may think about QEMU's parameter is very complicated, and there's a lot of complicated parameter have to establish a network or establish some graphic system. So it's complicated. It's hard to use that. So we also provide two different tools. One is the Verb Builder, and libverb project help you to establish a virtual machine for you, and very easy to use graphic system by a QEMU. So after that, I think you already know how to establish a Fedora development environment for RISC-V. Right now, you can download Fedora imaging and try it on your QEMU or real hardware. But before that, people may thinking about how can I how can I enable or boot up my system? So that's a question about firmware. Before you really start your system, you have to we have to build your firmware or install your firmware into your system. So there's some simple guideline for you how to install and build your firmware system. Let's for several months ago, I guess we still use this old build boot flow. What we have to build a kernel and then init RD and wrap it by BBL. So this is all boot flow for Fedora on RISC-V. It's very hard to let us very hard to really update the kernel, because every time when I install a kernel to somewhere, we need to read it up and flash it into a RHEL participation. So right now, we have a new boot flow for Fedora RISC-V. We can build open SPI and U-boot, then boot the Linux kernel and init RD from VFAT partition. So if you have a real hardware like Sci-Fi Unleashed, you can build open SPI and U-boot and get the DTB. This is the device tree blob, which include all the information about your hardware and boot the Linux kernel. So this is a new boot flow. From this diagram, you can see we just need to build this three parts of this software, and then we can build a real Fedora imaging. So let's the current build flow for firmware on RISC-V. We built DTB and then U-boot, then read it up by open SPI. Let make you easy to install or update Linux kernel and init RD. So before I finish my presentation, I will give you a very good news about Fedora firmware update, firmware development. So last year, we can see HPE engineer already made UEFI EDK2 running on a FPGA development board, which include USB 3 and PCIe 3. But after that, they are focused on standardized UEFI specification and other firmware specification for UEFI. So by that time, they haven't really opened their source code. But now, they already post their patch set for review. If you subscribe the UEFI, if you subscribe the UEFI mailing list, you can get this patch set. They also send a patch set directly to me and to some UEFI maintainer. So I already sorted out and pushed to my repo. So if you're interested about the UEFI development, you can contact with me. You can contact with HPE engineer directly. His name is Amber. So you can let me know, and I will give you the information about that. And now we are working together on running EDK2 on QEMU and Sci-Fi Unleashed. So we can see in the near future we can have a real software stack, really light server, boot from UEFI, boot from firmware to UEFI to GRUB, and then into a Linux system. So most of the them has been upstream. The final pieces is Tiano Core EDK2 and EFI step in kernel. So we haven't finished the EFI support in kernel. So thank you very much for all the people who contribute to this project. We are always open and hope we can have more help from the community. So, ありがとうございます。Thank you.
Thank you very much. We have only 2 minutes for questions. If you have question, please raise a hand. もし質問がありましたら、1人ぐらい。はい。
Yeah, I can take some question if interested. Yeah, okay, please.
Thank you for presentation. I'm Misono, and I'm a Linux kernel engineer at Fujitsu. So I'm interested in the Linux support for RISC-V.
Yeah.
So what is the current main active development area for Linux RISC-V in software stacks?
I think still a kernel driver, or because RISC-V standard, RISC-V specification haven't been really, including the interrupter controller, haven't been really, set up, or we haven't got a very full support in the hardware. So the software already been always change. So one of is the interrupter controller is some activity. I think there's some activity there. And also how to boot the Linux kernel. That's a big area. And we haven't really finished that. Because RISC-V is an open hardware, so some extension will get added in. So once you add some more extension, we need some driver or some other patch for that. So that's some activity. Yeah.
Okay, thank you. So
thank you.
You said HTTP engineer works for UEFI. So do you think
yes.
Do we need more work on firmware, or do we need more work on kernel side?
Do you mean, are you saying the hardware support, or yeah? For now, we're trying to use QEMU first. Make sure the simulator can run in first, and then we'll focus on existing existing Sci-Fi Unleashed board. Then, if you have a 64 core or 64 silicon, please contact with me. We would like to make it happen, make UEFI run on it. Yeah.
Thank you very much.
もし質問がありましたら、最後の質問。Do you have any question? Last question? Okay, thank you very much.
ありがとう。